Electrical machines work as generators, converting mechanical energy into electrical energy. Or as motors, converting electrical energy into mechanical energy. Electromagnetic induction was discovered by Michael Faraday in 1831. This phenomenon is the fundamental operating principle in all types of electrical generators. Faraday's law of induction describes the magnitude of the electromotive force induced in a wire loop, according to the formula. The induced EMF is proportional to the rate of change of the magnetic flux within the wire loop and the number of turns. Lenz's law states that the polarity of the induced EMF and the direction of the current arising in a wire loop from a changing magnetic field is such that the magnetic field created by the induced current opposes changes in the initial magnetic field. Therefore, it exerts a mechanical force which opposes the motion. Lenz's law defines the negative sign in the formula for the induced electromotive force. Inside a coil, a Hall sensor is placed which detects the magnetic field caused by a permanent magnet. The magnet is mounted on a pendulum. As the speed of the pendulum gradually decreases, the rate of change of the magnetic field decreases correspondingly, resulting in a decrease in the induction voltage across the coil. The induced voltage is alternating. Waveforms of the magnetic flux density, in green, and the induced EMF, in yellow, at different pendulum speeds. The operating principle of electric motors is based on the Laplace force, which is exerted on a current-carrying conductor in a homogeneous magnetic field. The Laplace force is defined by the relation. The direction of the Laplace force is determined by applying the right-hand rule. The Laplace force is a consequence of the Lorentz force acting on each charge inside the conductor. An experimental setup has been implemented to measure the Laplace force. Two 10 cm long neodymium magnets are placed on a metal base to create a strong magnetic field in the space between them. Using the appropriate instrument, a magnetic flux density of 533 milli-Tesla was measured. On a frame made with a 3D printer, 20 turns of wire have been wound. The frame is supported on a heavy base. Conductors on the underside of the frame are placed into the magnetic field. The base of magnets is mounted on a scale. The Laplace force on the conductors is of equal magnitude, but in the opposite direction, to the force on the magnet's base. This force is indirectly measured by multiplying the scale reading in kilograms by the acceleration of gravity. The error between the measured values of the force and the theoretical values is very small. The generator and motor functions occur simultaneously in every electrical machine. As a result, the operating current in a DC motor is defined by the formula, where EB is the back EMF, which is due to Faraday's law, and its value depends on the rotational speed. As the mechanical load increases, the speed decreases, and the current increases. At starting, the back EMF is 0, and the current is very high. The starting current is limited to 3 ampere by the power supply. By disconnecting the DC motor from the source, it works as a generator from its stored kinetic energy, and stops slowly, only due to mechanical friction. By connecting a 10 ohms resistor to the machine, it stops much faster, as current flows through the rotor conductors, and a Laplace force is developed in the opposite direction to the motion.